Hi girls, so here we start discussing about how frequency distribution can be made in Excel, right? So for that, I have a sheet here for you to just take you through the basics and then we go into the questions that are to be done. The questions that I've picked up are from Shruti Mathuroli and there are basically four questions that we'll be covering under frequency distribution. To start off with, let's start off. So there could be two sets of data, ungrouped and grouped data. Ungrouped data is basically raw data that has not been sorted into any groups, classes, range, interval, or whatever. So there is ungrouped data because we have to deal with all of this. So I'm taking you through this. So group data, group data would be data that has been organized into groups from raw data, right? So there's this classification, ungrouped and grouped data. Then we have that this group data can be classified into different kind of intervals. So what are these different kind of intervals? It could either be closed ended, it could either be open ended, or inclusive or exclusive. Now let's see what is a closed ended interval. You see the example here. I have these uh, classes 1 to 10, 10 to 20, 20 to 30. So where class limits are clearly defined, it's a closed ended interval. There is nothing left to our interpretation here. It's a closed ended. Vis-a-vis if you see a open ended interval. Here, if you see, what kind of intervals do we have below 10, 10 to 20, 20 and above. Here, if you see, the upper limit of the last class and the lower limit of first class, they're not very clear to us. It could be anything. Below 10, it could be anything. It could be 0 to 10. It could be 5 to 10. It could be 8 to 10. Left to our interpretation. Same goes here. 20 and above. What do you mean by 20 and above? Is it 20 to 30? Is it 20 to 40? What is it? So it has been left to our interpretation. Thus, these are open ended intervals. What do you mean by inclusive interval? Inclusive interval is that interval where the upper limits, if you see, they are included in their respective classes. Here you see 1 to 10, 10, which is the upper limit, is included in this respective class, right? In this particular interval. 11 to 20, 20 is the upper limit of this. So 20 is included. 21 to 30, 30 is included. What do you mean by exclusive? Where the upper limits are not included in interval. Like if you see 0 to 10 and 20, 10 to 20, now you will have to figure out where to put this 10, whether in this or in this interval, in this class or in this class. So here generally 10 will be placed in 10 to 20. 10 will not be placed in 0 to 10, it will be placed in 10 to 20. So this is an exclusive interval because the upper limits are not included in these in their respective intervals, right? Basis these four intervals, there could be four combinations of these, which could be inclusive open, inclusive close, exclusive open, right? And we further deal with questions which deal with each of these kind of combinations. Moving ahead, frequency function is an array function. All right. Now, there are two things which are peculiar to an array function. One is this, and the other one's this one. So, what is this? These are curly brackets, right? So, these curly brackets around the formula indicate that the formula is an array formula or an array function. When you talk about frequency, frequency is also an array function. All right. Now, what happens is that just think about any formula or function that we write in Excel. We write the formula, we start with an is equal to sign. We write the formula, and when we are done, if you want to copy paste the formula into the following column, we just drag it or copy paste, and the formula gets pasted and it gives us returns us values. But what happens in array function, it will not give us correct results if We write the formula in one cell and then copy it down to another. Array function works little differently. Here, what we have to do is that if I want to find out frequency, I will not select one cell and write the formula, but rather wherever I need the frequency, I'll select that particular range of cells, that particular array of cells. You understand the word array? It's a range, a selection of cells, reference to a set of values. So I will have to select a particular range of cells and I will write my frequency function. When I write my frequency function, now nowhere am I telling you that you have to place these curly brackets yourself. When I write my frequency function, because it's an array function, we just don't press enter simply. We rather have to press Control Shift and enter simultaneously. When we do that, these curly brackets get placed themselves by Excel, and Excel returns us the values for all the frequencies that we wanted, for all the particular columns that we wanted. So these are two peculiar things about an array function. Always remember that frequency is an array function. You just don't type the frequency formula. You can see here the frequency formula, the frequency function, the syntax is equal to frequency bracket open bracket close. What is it asking for? The arguments are data array and bins array. What's the data array? Data array is the data that has to be sorted into the class intervals. So it's basically a raw data, something that has not been sorted, the ungrouped data, right? So we make a selection of all of that data. And what's bins array? In our case, array of largest value that are included in the intervals, right? So that's the syntax or the function for your frequency. And obviously we'll understand how it's an array function when we do the question, but just keep in mind that the function, the formula of frequency is not to be just typed in the cell directly. You have to make selection of the cells where you want the frequencies, then you type in this and press Control Shift Enter simultaneously. The curly brackets will appear and will also give you the resultant frequencies, right? This here that I've made is a general set of column heads that we need when we're doing the question. So I've just mentioned it here again for your little convenience and just to give you a backdrop or a little bird's eye view of what we're going to do in the questions. If you see frequency distribution as a topic, it's not at all difficult. So just again coming back, so the column heads are lower limit, upper limit. You know, when I was telling you about the intervals here, the classes that we have here, so these are the lower limits, these are the upper limits, right? So lower limit, upper limit, bins, I told you these are the array of largest values. In some questions you will see the upper limits themselves become the bins. In some questions you might see that we have to calculate the bins, right? Then what is frequency? I'll come to midpoint. What is frequency? You know the function for it, the syntax for it. You calculate the frequency. You have the summation here, sigma f. So you just sum of all the frequencies. Then we need the midpoint, right? So midpoint or x. How do you get that? You do the averaging of these limits. What do? You say is equal to lower limit plus upper limit by 2. You get the midpoint. So this is your x. This is your frequency is your f. To get an fx, what do? You multiply frequency with your x, right? So fx, then again you have the summation here, sigma fx, and what is this? Fx square. So you already have the fx here. You again multiply it by x, you get fx square, summation of these. Why do we need summations of these? I'll tell you. First, if you have a look here, again coming to group data and ungrouped data. When you have to get some statistical parameters for an ungrouped set of data, you can easily just there are inbuilt functions in Excel for them. So you can easily, just start your formula, your function within is equal to sign, and you write the words here. Like for mean, you just have to write is equal to average. You open the brackets and it'll ask you for the arguments. You put those arguments and you're done with it. Argument is generally the set of ungrouped data. So this is basically the set of ungrouped data. So be it be whatever, mean, standard deviation, mode, skewness, kurtosis, median, largest number in the range, smallest number in the range. If it is of the ungrouped data, you can easily find it through the inbuilt functions of Excel. But here in frequency distribution, we are dealing with group data. It has become into classes, into intervals. So how do you find out mean? Mean is sigma fx by sigma f. Thus we have the summation sigma fx by sigma f. What is standard deviation? Square root of SQRT stands for square root. Sigma fx square by sigma f. So sigma fx square by sigma f minus mean square. Mean we would have already taken out here. We just have to reference this cell here. So square root sigma fx square divided by sigma f minus mean square. And what else is generally asked? So when we start doing the questions, you will see what all is required is it might ask you for some statistical parameters of the ungrouped data, which are again you can see very easy to find. Then you will be asked to make these classes, these intervals, and find out mean and standard deviation. Also, they would ask you to make a pie chart. You know how to make a pie chart. You just go to insert, you go to charts, you insert the pie chart. Again, very simple. Heading onwards, let's have a look at the question that we have here, right? So the first category, like I told you, there are 4 combinations, and based on those 4 combinations of intervals, we'll have 4 questions. So let's start off with the first question. These questions that you see here, I've taken up from Shruti Matharoli because I assume that some of you might not have the books. So I've made a PDF here of the questions for your easy accessibility. So let's have a look at what the question says and what is expected from us to be done. It says prepare a spreadsheet in Excel to classify earned leave data of 100 employees. So if it's saying 100 employees, that means we'll be dealing with data of 100 employees. So frequency is, the total of the frequency will be 100. You're clear? Anyways, uh, classify earned leave data of 100 employees of a government department at time of retirement. Classify according to the following class. Now, if you look at the classes, the lower limits, the upper limits are given to us. 1 to 60, 61 to 120, 121 to 180, 181 to 240, 241 to 300. So first thing that we see is that it's a closed set of data, right? The class intervals are closed. It's not open. It's not open to our imagination, right? Another thing that we see is that the upper limits are inclusive in the sense that they fall into their respective classes and not the next set of class. So it's 1 to 60. Had it been 1 to 60 here and 60 to 120, it would have been exclusive. But here we are dealing with inclusive. Okay, so they have given us the limits. Generate the number of earned leaves accumulated by 100 employees. These leaves vary between 1 to 300, generated at random. So you know what function has to go in there? Rand between function. So we'll have a rand between function 1 to 300, and we'll generate data for 100 employees. Correct? Then it says fix the values using appropriate function in Excel. Compute the statistical parameters such as mean, standard deviation, mode, skewness, kurtosis, median, largest value, smallest value from the ungrouped data. It's not asking us to calculate all of this for grouped. For ungrouped, it is asking us to do this. If you remember our Excel sheet here, for ungrouped data, you remember this is how you calculate your statistical parameters. Coming back, classify the data on the basis of the above class intervals to create a frequency distribution. So it's asking us to make a frequency distribution for which we'll make this particular set of table and calculate frequency. You remember frequency is an array function. Calculate mean and standard deviation of the group data. Now it's asking us to calculate mean and standard deviation of the group data. You know how it has to be calculated. You'll have a look here. prepare a pie chart for the above frequency distribution, right? So let's go to doing this on Excel now. First thing that it said was that we have to uh, have earned leaves for 100 people. Now, what you see here, this is volatile data. You see, I've mentioned here volatile data. This set of data is volatile data because this has come through this function, which is equal to rand between 1 comma 300. Wherever you select the cells here, you will see the function is visible. And because it's random data, it'll keep on getting changed multiple times. For example, if you see, the moment I click any cell, the data keeps on changing. See, if I click here, it'll again change. The whole set of volatile data is changing. Now, obviously it'll change because we inserted the random function here. But we can't work with random data if it keeps on changing. We need to make this volatile data into fixed data for the purpose of doing our further calculations, which is basically frequency distribution and your statistical parameters, mean, standard deviation for group data, right? So once we are done with this step, we have created volatile data for 100 members. What did I do? I just went to this cell and wrote this function, ran between 1 to 300, and I copy pasted this formula across 10 columns and 10 rows, which gave me a set of 100 values which are generated at random. So this is my volatile data. Now, because I cannot work on volatile sort of data, because you can see it keeps on changing, I have to make it fixed data. How do I make it fixed data? I pick up my data from here. You can see the values are not same as of now because obviously the moment that I would have picked them up, they must have been different, and now they're different. So basically what you do is you pick your random data and copy paste it into other set of rows and columns, other set of rows rather, not columns, other set of rows. Now if you directly copy paste it, then the values will come along with the formulas, but you don't want the rand function to be here, right? So when you copy paste it, you do a paste special, or you say paste just the values, right? So I'll just show you. So if I say copy, I can go to paste and it says if you want to paste just the values or what. So I can just paste the values here, you see, and again the data have changed here, but the data that I just pasted here is the earlier one. And if you see this data that I just pasted, these are just values. It does not contain that formula, and thus this will not keep on getting changed. Okay, so this is my fixed data. This is how I got the fixed data. Coming back, this is how I got my fixed data here, right? You do a paste special or you do paste values depending upon what OS you're using and how you're which version of MS Office you're using. You always have this option of pasting just the values. So number one step is creating volatile data, and number two step is fixing the data. So you remember in the question also it had asked us generate random data and then fix the values. So we're done with fix the values. These are the values, right? We move ahead and we say that let's get to doing the main thing, which is this table, inclusive close-ended in class intervals, and I take these column heads. Okay, now if you see here, we generally like to leave this as blank because here we have this hyphen denoting 2. So 1 to 60, 61 to 120. All right. Now, though in the question directly these limits are given to us, we do not hard code them. We will just see, we'll just hard code one here, the lower limit of the first interval, and moving onwards, we will say, you see the formula here? What is the formula? The formula is that this lower limit plus 60, and I have then copy pasted this formula till here. You can see these are all formulas, these are not hard coded numbers. Same for the lower limit, I had hard coded 60 and then put the formula that upper limit plus 60, because whatever the range is, you see this range is 60, the difference is 60. 61 minus 1, 60, 120 minus 60, 60. So we fill these like this. Then what are bins? We know bins are the upper limits. So I haven't, in a lot of questions you will see they don't, if the bins are equal to upper limit, they don't make this column, but I've made this column because we want clarity, right? So my bins are these particular numbers only, right? So I've just said the cell referencing has been done here. Now frequency, now let me show you how we take out the frequency. I told you frequency is an array function. Okay, so I have already done it here, but I'll do it here also to show you what has to be done. So let's say that I have to take out frequency in this column. I'm doing it just to show you, otherwise it is done here only. Okay, so here I'm doing it to just show you. So the first thing that you do in an array function is that you select the cells where you want the values. Okay, you select them, then you start writing your syntax for whatever function. So here we have frequency as the function, so the syntax is equal to frequency data array. I will choose this data array bins. I will choose these bins. Now what has to be done? I will not straight away press enter. I have to press Control Shift and enter simultaneously, and it has given me the values, right? See, the values are same: 15, 27, 24, 15, 19. Had I done it this way, is equal to frequency data array comma bins, the normal way, right? It's still giving me 15, but let's have a look at these values. Is it giving me the same values as this? No. So you will not get the correct results in frequency if you just calculate in the active cell and then try to copy it down the column. Okay, so frequency, always remember, is an array function, and therefore two conditions of array, I've already told you these two conditions. Press control plus shift plus enter together, and while you're writing your formula, you select all these cells and just have a look at the formula in the formula bar here. You see these curly brackets have appeared. Did I put them? I did not, but because I had selected the cells together and because it's an array function, the curly brackets appeared themselves. Alright, so this is one thing that you have to remember about frequency. I'm taking it out from here so that it does not cause you any sort of confusion. Just wanted to explain you. Frequency, I've got the frequency. How do I get the mean? It is sigma fx by sigma f. For sigma fx, I first of all need the x. X is what? Lower limit plus upper limit divided by 2. Let's have a look at the formula here. It's this, basically averaging of the limits. All right, that's the midpoint. Fx, you know, would be frequency into the midpoint, correct? It's this, again dragged and dropped. These are the summatations. You know how to do the summatations, is equal to sum formula. Here also some formula, here also some formula. Okay, this is fx square. What do? I have the fx into x. Have a look at the formula. It is fx into x, fx square. Here I have the summatations, statistical parameters of group data. How do I find out the mean? Mean is sigma fx by sigma f. We will always use the cell referencing. What is the standard deviation? Standard deviation is square root, then sigma fx square divide by sigma f minus mean square. Mean I had already taken out here, so minus mean square. This is when we do it through the formulas of the group data. Had I taken out mean and standard deviation according to the formulas which are there for the ungrouped data, for mean it's just the average, for standard deviation is it's STDEV. Have a look here. I've just taken out these according to ungrouped data. Average of basically all of this is giving me mean. You will see the mean is very close. But however, we will go for group data. When it's asking us for group data, we'll go for this. And again, if you see the standard deviation of ungrouped data, STDEV of ungrouped data, all of this data is selected. And again, it's also close. So one thing that was to be done was this. What else is required is this pie chart. How do you make this pie chart? You will select your frequencies. Okay, select your frequencies. Don't select the, select just the values. Don't select the column head. Okay, so select your values. You go to insert, you go to chart, you go to pie chart. It might look a little different in my system because this is an OS, it's a Mac, but you get the idea. It's very simple. You go to 2D pie. This is how you get your 2D pie. Now, if I want the values here, what do I have to do? I will go to chart layout. This is the legend. Legend is these entries. They are already to the right. I will just change them. Before that, let's have chart title. Title above chart. You can just mention frequency distribution in here. No worries about that. What else can we do? Can I have the data labels, values I got? And about this, how do I go about this? I will select this, select data, and category X, X's labels. I will just say that I want these limits to be mentioned in there. Okay, and I'll say okay, and it's done. Correct? So that is how you put a pie chart. I'll just again remove it because I've already done it, so no need to have another pie chart here. That's the basic idea of a pie chart. And that is one simple question on inclusive close-ended class intervals done. Now let's move on to next question. So for that, let's have a look at the question first. Next combination is inclusive open-ended, and the question also deals with the same set of inclusive open-ended intervals. It's asking us to prepare a sheet to classify the earned leave data of 100 employees at the time of retirement. The intervals are given now. You look at the interval, the moment you see this word and above, you can realize it's an open-ended class interval. And above it could be anything left to our interpretation, like I always say. So this is an open-ended thing. And let's have a look at the upper limits. Are they in which range are they following? Are they following in the same class or another? 1 to 50, 51 to 100. That means it is inclusive, not exclusive. All right. Let's have a look at the question. The questions would generally be the same. Generate the number of earned leaves accumulated by 100 employees. Leaves vary between 1 to 300. Again, generated at random. That means ran between का formula लगेगा. Ran between 1 to 300. Fix the values. Use appropriate functions for all these statistical parameters for the ungrouped data. Classify the data on basis of above class intervals to create a frequency distribution. Calculate mean and standard deviation of group data. Pie chart for the frequency distribution. Question is generally the same. You have to pay your attention here that what kind of intervals do they have. Alright, and that will only make the difference in how we do the question. Very slight, very small differences, very small points of difference. Now, there are two problems in this question. First is that if we have this word and above, then what should be the bins array? Because in bins array we always say upper limit is the bins array. That is one problem. Another point of problem is that how do you calculate the midpoint of the interval, which is open-ended? How do we address these two problems? For bins array, as the last upper limit is open-ended, in bins array, we will not select the upper limit as the bins. And because the last bin will be empty, when we are calculating frequency, will not take into consideration the empty bin. Okay, so that's how we deal with bins array. And how about the midpoint of the last interval? Now, midpoint of the last interval will not be calculated by the formula like we were doing lower limit plus upper limit by 2, will not calculate it that way, but we'll just type assuming that the size of the last interval must be same as the size of other intervals. So we'll ourselves write x's value, the midpoint, because we want to proceed with the question. So these are the only two differences in doing the question. Let's have a look at the question now. So here is my volatile data, ran between 1 to 300. You can see I had generated this. First part is you write is equal to ran between 1 to 300, and I have these 100 values here because it asked me for data of 100 employees, right? Then I have to fix the data. I copy the data from here and do a paste special or paste only values, and I fix the data, right? Moving forward, you look at the limits. You remember I had told you we don't type the limits. We will just type 1 and 50, and these 51 and 101, 151, they are calculated because we say that there is a specific range. So this cell plus 50, it will become 51. Again, this cell is this plus 50. So we go on calculating this. But when we reach here, you remember the question is an open-ended one. We will have to type these words and above. Okay. I told you I will not, because here in the last interval we don't have the upper limit, thus we will not have the bin also. Otherwise, how do we calculate bins? Bins are equal to the upper limits, right? Is equal to E29, which is this, right? Rest are also the same. If you see frequency is also calculated like I told you before. Okay, the only difference being because we don't have bins here, I'll just show you actually. So frequency we are calculating, we first select the cells, right? Is equal to frequency data array is this. Now the point of difference being bins array is not this but this, right? And then Control Shift Enter. Okay, so that's how we get the frequencies. You see they're same 18, 23, 19, 14, 26. They're the same. That's how you calculate your frequencies. So basically we don't have anything here in the bins. And for midpoint, let's come to the midpoint. You know the formula, it's equal to lower limit plus upper limit by 2. You drag the formula, but here because it is and above, you don't have the upper limit. So we just type in this basis that the size of the interval would be same as this. So if it's 151 to 200, it would be 201 to 250, and the midpoint would be 225.5. So we have assumed this and we have hard coded typed it. Okay, this does not come with this formula that we have here, right? Then you have your simple f into x, their summation, fx square, the statistical parameters, mean, standard deviation, and your pie chart. So it's all the same, the only difference being that the bin, because we don't have the upper limit of the last interval, the bin remains empty, and this midpoint, it is assumed and not calculated through the formula but typed. That is the difference. Go to next question. Next question is that of exclusive close-ended intervals. The question is the same, earned leave data for 100 employees. Now, main focus is this, right? Otherwise, if you see the question, it's almost the same. It's asking us the same things to do. So let's pay our attention here. If you see the lower limits, 0 to 60, okay, 60 to 120, 120 to 180, 180 to 240, 240 to 300, these are the classes. These are the lower and upper limits. Now, obviously, this is not open, this is a closed thing, so closed. But is it inclusive or exclusive? It's exclusive. Why? Because the upper limit of this class is the lower limit of this class. Same, upper limit here, 120, is the lower limit here. And we can get confused that where exactly will the 60 fit in? Will it go in this class, 0 to 60, or will it go in this class, 60 to 120? In these cases, like I told you, in exclusive close-ended class intervals, the upper limit will be considered in the next class. So 60 will be considered in this class, 60 to 120, not in 0 to 60, right? So when we have this kind of question, what do we do? Again, the problem or the point of difference that you can already see is arising in case of bins, right? Because when we are writing values in bins column, we directly used to say the upper limit is can be transferred to the bins column, the upper limits. But here, if you see, because intervals are exclusive, upper limits cannot be used as bins array, because here the largest value in any interval is actually the upper limit less 1. 60 is not falling here, 60 is falling here. So the largest limit in this class is 60 minus 1, which is 59. Here 120 is not falling in this class, 60 to 120, it's falling in this 120 to 180. So in this class, 60 to 120, the largest value is 120 minus 1, 119. So there is a little difference in how we calculate the bins, and that is the only difference. The rest, everything remains the same. Let's have a look at the solution to this question. Here again I have the set of volatile data. I have, oh, no, not this question, I'm sorry. Next question, yeah, this one. Exclusive close-ended class interval question. So my volatile data ran between function, right? Then fixed data. Then I made these column heads. I've not done the chart and mean and standard deviation. They're just the same. So can be easily done. The only point of difference is this, the one that's highlighted here. So I'm just gonna focus on that here. We have the lower limits here. Again, we don't type the numbers, we would use the formula 0 plus 60, 60 plus 60, that ways, right? And here in bins, what do? We say upper limit minus 1. You know why we are doing that? Because the intervals are exclusive. Upper limits cannot be directly used as bins. The largest value in any class is upper limit minus 1. So upper limit minus 1 becomes your bins. Now this will be dragged, yeah, this will be dragged till here, right? Copied or drag, whatever you're doing, till here. But in the last class, bin is exactly the same as the upper limit, right? So for the last class, you don't do minus 1, it is the same, because we don't have any further classes where uh, uh, it is gonna go into. So here it is exactly equal to the upper limit, the bin here. Rest everything remains the same way you calculate your frequency, your midpoints, fx square, your summatations, also your, I have not done here but I'll show you in the previous sheet, your statistical parameters, your pie chart, everything remains the same. Now we'll quickly move to the last combination of class intervals, which is exclusive open-ended. We have done exclusive close-ended. Let's have a look at the exclusive close open-ended question. Here you see it's asking us the same things. It wants data of 100 employees. This is the table that it has given us. Rest of the things that you see in the question are exactly the same. So for you to just have a look, the same things are required to be done. What is different here? You see this word and above. So this signifies that it is an open-ended class interval. And why exclusive? Because the upper limit of the class interval is not inclusive in the class, that in its own class, but rather it becomes the lower limit of other class. So 0 to 50, 50 to 100, 100 to 150, 150 to 200. It's just showing that it's an exclusive set of data, exclusive set of class intervals, sorry, right? So how do we deal with this now? First of all, let's try to identify what were the things that had to be done when it was an open-ended statement, and what were the things that had to be done if it was an exclusive statement. We have just done one question of exclusive closed-ended class intervals, and we saw because these values are exclusive and not inclusive, we had the problem with bins. Bins, we could not directly say that the upper limit is the bin array. We had to say upper limit minus 1. So that was one point for exclusive. How about open ended? What was the problem in open ended? First, this word is creating the problem, and above. So in this last class, you remember we did not create the bin altogether. And as far as the midpoint goes, the x goes, we did not calculate it, but we had assumed it, that because the size of the intervals would be same, assumed hypothetically, and we had typed the number. So these are things that we are going to do in our solution also. Let's have a look. Volatile data, fixed data, you know this is RAND between. This is your fixed data, exclusive open-ended. These are your lower limits, upper limits. Bins, you know I've done upper limit minus 1. When I reach to this last class, I will not copy the formula because I have this word and above here, right? So I will leave this bin empty. Okay. Frequency, how is it calculated? Frequency will have the data array will be this all data that we have in the fixed data, but for bins array we will just choose 49, 99, 149 and 199. We will not select the empty cell while we are calculating frequency. Again, I will just show you how we have calculated frequency. So select the cells, you start with your frequency formula, data array, this whole set of fixed data is your data array, and your bins array is just this much. The last class will not have bins, right? Then what do we do? Control, shift and enter. Same values 23, 15, 14, 18, 30. That is how you calculate your frequency. You see in the frequency formula, your curly brackets have appeared on their own, showing that this is a array formula. Okay. Same way, midpoint has to be calculated, lower limit plus upper limit by 2, right? But you see, I have dragged this formula till 175, till here, see. But when it comes to writing this value, this is a hard-coded number. You can see there's no formula here. This is a hard-coded number on the assumption that the class range or the size of the interval would be same. So if it's 50, here the upper limit might be 250, the midpoint would be 225. And again, you get the fx square, you get the summatations, you can, like I had shown you, you can get your mean and your standard deviations and put your pie chart in place. So that is how all 4 combinations, all 4 kinds of class intervals are done in frequency distribution, and that's about frequency distribution. There's nothing more to it.